today, we're going to go back to our unit circle. Today's date is 12/5/18. Okay? So, in the unit circle, what happens is this. If this is an x and a y-axis, okay, I want you to watch what I'm going to draw, okay? X, y-axis, then really, this circle is on an xy plane, right? Now, if I were to draw this circle on the xy plane, it would be this little, because the radius is 1, right? So the coordinate of this would be 1, 0, 0, 1, and it'd be a -1, 0, and a 0, -1, right? And then we'd have all these other angles, but they'd be really squished, right? You guys agree? We'd have all these other angles, but they'd be really squished. So when I look at my unit circle here, it's really this circle on the grid, okay, on the xy plane. X-axis, y-axis, right? So we got that? Now, that means that I'm going to have some coordinates, okay? So my coordinates would be here. This would be the point at 1, 0, right? This point up here would be the coordinate at 0, 1. This coordinate over here would be at the coordinate -1, 0. Cody, Ben. Coordinate of this point is at 0, -1. Okay? Everybody got it? Now the problem is that at 30 degrees and at 45 and at 60, we also have coordinates. Okay? So we also have what's the coordinate of this. So if I go back to my grid, right there we should have some point, right? Well, the way we get these points is by creating our 30, 60, 90 triangles, okay? Or our 45, 45. So real quickly, we did this yesterday or 2 days ago. We knew that if we had a 45, just watch, 45, 90. We're talking about that one there, right? We knew if this side was 1, this turned out to be the square root of 2 over 2. Oh, if this were 1, this turned out to be the square root of 2 over 2. And this is also the square root of 2 over 2, right? So if I need a point right here, I'd go out, square root of 2 over 2, up, square root of 2 over 2. So the coordinate of this point would be square root of 2 over 2, square root of 2 over 2. Okay, that makes sense, right? So if I go to my unit circle, slap that on, I really have a 45, 45, 90 triangle. The coordinate of that point would be out, square root of 2 over 2, up, square root of 2 over 2. Okay? Make sense? Now I'd have another 45, 45, 90 triangle here, except for its back. So the y value would be negative, right? It'd go back square root of 2 over 2, and then up square root of 2 over 2. So its coordinate right here would be at negative square root of 2 over 2, and then positive square root of 2 over 2. I have another 45, 45, 90 triangle here, except for this one's back and down. So the only difference is its coordinate would be at negative square root of 2 over 2, negative square root of 2 over 2. You guys are going to need to know this when you go into Mr. Massey's class, because he will not let you use your notes. You're going to have this memorized. That's why I want to teach you how it works. So you can recreate it pretty easily, because it's not hard to recreate. So then if I go to 315, it's the same 45, 45, right? But it's back, it's over forward x, and then down y's. So it would be a positive square root of 3 over 2, square root of 2 over 2, my bad, and a negative square root of 2 over 2, okay? So you can see all the 45s. Good luck, girls. Now, if I go back to my triangles, and if I take a look at this triangle that we did a couple of days ago, and I had my 30, 60, 90 triangle. If this is 1, it's that one there, right? It's that one there. Then this side is 1/2, and this side is the square root of 3 over 2. So if I looked at this triangle right here, its coordinate would be this length, which we know is 1/2, and this height, which we know is the square root of 3 over 2. So its coordinate is going to be a 1/2 and a square root of 3 over 2. We got another one right here at 120. Same triangle. Okay, we got another one here at 120, except for it's the back and then up. So the coordinate at 120 degrees is a negative 1/2 and a positive square root of 3 over 2. We got another 30, 60, 90 triangle right here at 240, except for you got to go back 1/2 and down the square root of 3 over 2. So its coordinate would be a negative 1/2 and a negative square root of 3 over 2. And then we've got another 30, 60, 90 triangle right here at 300 degrees. It would be forward 1/2 and down the square root of 3 over 2. So its coordinate would be positive 1/2, negative square root of 3 over 2. Okay? Now, we've got these triangles at 30 degrees. It's just the other triangle. It is this triangle, but turned over. So if I take this triangle and draw it this way, where the 30 degrees is here, we'd have, this is my 1/2, this is my square root of 3 over 2 if the length is 1. So if I take this triangle over square root of 3 over 2, up 1/2, okay? Will you two boys please go outside and talk? And then when I'm done, I'll bring you back in, okay? Because I'm trying to teach. Okay, so over square root of 3 over 2, up 1/2, square root of 3 over 2, 1/2. But I'm going to recreate this triangle all the way around, okay? So the difference is this one's negative and then positive. So this would be a negative square root of 3 over 2 and a negative 1/2. This triangle is the exact same triangle, but it's back, which is negative, and down, which is negative. So the coordinate of this is going to be a negative square root of 3 over 2 and a negative 1/2. You guys aren't good. Katie's copying. You guys aren't copying this down?
We were until we just kind of got too fast and just lost it.
Okay. Well, it's all going to be here in a second, okay? So then this is also another 30, 60, 90 triangle, right? But it's forward. It's forward. Thank you. It's forward square root of 3 over 2 and down a 1/2. So its coordinate would be a positive square root of 3 over 2 and a negative 1/2, okay? So if you don't have all of these, I'm putting them up here eventually, but these are all the individual coordinates, the points. These are the points that if I were on a piece of graph paper, these would be the coordinates of the points on a piece of graph paper, okay? Except for it's blown up really big so we can fit it all on there, okay? Because technically it's really itty-bitty, but we'd never be able to get it on there, okay? So big deal. Who cares? Well, let's take a look. Let's see why this is important, okay? Let me slide this down for a second, okay? So what do we know about sine? Sine is, we just learned that sine is the y over the r, right? The sine is the y over the r, correct? But what's the radius of the unit circle? 1. So the sine is just is equal to the y value. Here's how it's going to work. Please watch. And you can try it on your calculator. But the sine of 30 degrees is equal to 1/2. Try it on your calculator. Sine of 30. Sine of 30 will give you 0.5. If you tried sine of 60, it's going to be square root of 3 over 2. But your calculator will give you a decimal answer, but it is exactly the square root of 3 over 2. Because the sine is just the y value. Now the cosine, we said, is the x over the r, right? But the x value is the quarter of the x value, but the radius is 1, right? So it's just the x value, okay? So if I wanted to find the cosine of 120, it's the x value. It's negative 1/2. You can try it in your calculator. Go cosine of 120 degrees, and you will get negative 1/2.
Where do you find?
I don't think you're lying to us.
Yep.
Where do you find the cosine things?
We're right here.
Oh,
Thank you, Cody.
wow.
Okay. Now, what about tangent? Tangent's the y over the x, okay? So if I did the tangent of 0, if tangent's y over x, the tangent of 0 is going to be 0 over 1, which is just 0. If you use your calculator and do tangent 0, you'll get 0. The tangent of 45,
Okay.
the tangent of 45 is this over this. Square root of 2 over 2 over square root of 2 over 2. But that's just 1, isn't it? Okay? So, let me go ahead and fill this in, you guys. I will stop the recording, and then we're going to do some things. Oh, yeah. We're going to do some things on the homework together, all right?
And then just